All right, guys, so on this video, we're going to cover the last section of Chapter 8. We're going to review the last section that we covered, which was difference of two squares, by doing this class opener. And we do have a perfect square term right here, and we do have a perfect square term right here, and there is a difference between them. So we're going to square root the first one, the square root of 9y squared, that is 3y. The square root of 49h squared, that is 7h. So we're going to repeat that, 3y and 7h, and we're going to put 1 plus and 1 minus. They have to be opposite signs in order for the middle term to disappear if you were to distribute and combine like terms. Again, this is this is from the previous lesson. You guys should remember how to do this. That's why I'm not taking that much time explaining it. Number 2, we do have a difference, but these are not perfect square terms. So you can't do that yet, but you could pull out a GCF. When you look at the binomial, 8 and 50 do have something in common. They have a 2 in common, but they also have x's and they also have y's. So the maximum amount of x's you could pull out is one of them, and there is one y that you could also pull out. That's your GCF. So 2xy times what will get you the 8x to the third y? Well, 2 times 4, that'll give you 8, and the x times x squared, that'll give you x to the third. And of course, the y times 1 will give you y, and it's pointless to put a y, so you don't need to put anything right there. And then 2xy times what gets us a negative 50xy? That would simply be a negative 25, right? 2 times negative 25 is a negative 50. The xy times 1 gets you the xy. You don't need a times 1. So after pulling out the GCF, if you look at the inside, we do have a difference of two perfect square terms. So I am going to square root that first perfect square term, and I'm going to square root the second perfect square term, and I'm going to plug it into my difference of two squareds format when we factor. So the square root of 4x squared is, anybody? 2x, and the square root of 25, 5. So you have the 2x and the 5. And of course, the signs have to be different. And what about that GCF that we pulled out? We bring that down. Ladies and gentlemen, this is the final factored form of number 2. Moving on to number 3. Do we have a perfect square term here? Yes, we do have a perfect square term there. However, this is not a difference of two squares. It's an addition, so you can't really apply the difference of two squares method. And also, if you try to pull out a GCF, there's nothing in common with 9 and 25. So there's absolutely nothing you could do. I would say not factorable, but the back of your worksheets say prime. Prime just means not factorable, that you cannot factor it. So you could only do the difference of two squares when you have a difference, which is minus. Moving on to number 4 right here. Do we have a difference of two perfect square terms? The answer is yes. We do have a difference. Let's do the square root of 1, and let's do the square root of 64p squared and plug it into our factored format here. So what's the square root of 1? It's 1. What's the square root of 64p squared? That is 8 with a p. So let's repeat those two answers, 1 and 8 with a p. And of course, because it's a binomial, that means that if I were to start distributing 1 times 1, 1 times 8p, and then 8p times 1, that means that when I combine like terms, the middle terms have to cancel out. And the only way that's going to happen is if you have opposite signs, a minus and a plus. Number 5, which says 4. Sorry, that's supposed to be a 5. This one's obviously not a difference of two squares. This is a regular quadratic trinomial, and the a value is 9. You can't pull out a GCF from all of them, so we're stuck. We have to go with the long method. Step 1 of the long method is to multiply a times c. A is 9, c is 4, a times c is 36. Step 2 is to think of the multiples of 36. 1 times 36, 2 times 18, 3 times 9, no, 3 times 12, sorry, 4 times 9, and 6 times 6. So when I think of which pair of numbers combines together to give us the middle value, negative 12, I know that 6 and 6 gives us a positive 12, but the b value is actually a negative 12. So I have the right numbers that just have the wrong signs. So instead of positive 6 times positive 6, I want to change it to a negative 6 times negative 6. That's the right pair of numbers that we want for step 2, not the positive 6s. Anyhow, step 3, you could change your trinomial to a polynomial to use factoring by grouping, but I'm going to use the shortcut, that magic shortcut where you put the parentheses and you put ax right here and ax right there. The a is 9. Of course, we're going to put it with a single x. So I put a 9x right here, a 9x right there, and in this blank spot and this blank spot, I simply take the pair of numbers from step 2 and put them in right there. So I'm going to put a minus 6 right there and a minus 6 right there. The final fourth magical step in this shortcut process is to divide both of these by whatever you can. So 9 and 6, you could divide both of them by what? 3. So 9 divided by 3 is a 3 with an x. 6 divided by 3 is a 2 with a minus sign. And again, over here, divide this also by 3 and this one by 3. And you're going to end up with the same exact binomial, 3x minus 2. And just for the record, whenever you do have the same exact binomial times the same exact binomial, it could be rewritten as a single binomial, 3x minus 2 to the second power. Sometimes they do that in multiple choice tests. Just wanted to let you know about it. Anyway, we're moving on to today's section. And in today's section, we're going to be factoring perfect square quadratic trinomials. So if we read along right here, in a standard form quadratic trinomial, ax squared plus bx plus c, if the a value and the c value, if this guy and this guy are perfect square values, then you may have a perfect square quadratic trinomial. So what is a perfect square quadratic trinomial? It's when you have a perfect square term in the front and a perfect square term in the back. It's kind of like up here, we had a perfect square term right here and a perfect square term back here, but it's only a binomial right here. Down here, it's a trinomial, okay? So if you do have a perfect square term here and a perfect square term there, you may have a perfect square quadratic trinomial. So all you have to do, it says, use a shortcut, square root the a, square root the c, and then plug it into your answer format, parentheses, parentheses. And it says with the appropriate symbols. So I left blank spots right here because it all depends on your b value. You're not going to have opposite symbols. Back when we had perfect square binomials, where you had the difference of two squares, you didn't have a middle term, which meant that you had to have a plus and you had to have a minus. Right here you do have a middle term, so whatever that middle term is, if it's a plus, both of these are going to be pluses. If it's a minus, both of these are going to be minuses. I guess the best way to understand this is to actually apply it. So check it out. We have a perfect square quadratic trinomial right here, and we're going to factor it. Now, how do I know it's a perfect square quadratic trinomial? Well, first I identify that I have a perfect square term in the front and a perfect square term in the back. Yay? Now, I'm going to plug it into my answer format, my factored form answer format. I'm going to do the square root of 9x squared. What is the square root of 9x squared? 3x. What's the square root of 4? 2. What's the square root of 9x squared? 3x. What's the square root of 4? 2. Now, on the previous section, we did not have this middle term. We had just a perfect square binomial. We had the difference of two squares. We didn't have a middle term. That's why we had to have one plus and one minus. That way the middle term would cancel out. But right here we do have a middle term. So we need to end up with a 12x. And it's negative. So what symbols belong right here? If this middle term is negative, then you have to have both of them being negative. Right? So let's put a minus here and a minus there. If they were opposites, if one was negative and one was positive, then they would eliminate. You wouldn't have this negative 12x. Let me just show you. As a matter of fact, once you put it in this format, it says that you need to check it, right? You need to check it. Right here, the last thing I say on the notes, always check your factored form answer by distributing. So you have your factored form answer right there, but you need to distribute to see if it actually works. So 3x times 3x, that's 9x squared. 3x times negative 2, that's negative 6x. And then negative 2 times 3x, that's another negative 6x. And negative 2 times negative 2, that's positive 4. And the middle terms really do end up being negative 12x when you combine them. So you do have a 9x squared minus 12x plus 4. And as you could see, bless you, it's the same exact quadratic trinomial as what we started with. Okay? So the only difference between section 8.8 and 8.9 was that 8.8, we had a binomial, 2 terms, and both of them were perfect square terms. The first one was a perfect square, the last one was a perfect square, and there was no middle term. So we square rooted each of them, plugged it into our answers, right? Right there and right there. And then we had to have a plus and a minus because the middle term must cancel out. And today we have a perfect square term in the front, a perfect square term in the back, and we square root them and plug them into our answer format right there and right there. But you can't have opposite signs because that would eliminate the middle value. You need the middle value, and whatever that middle value is, if it's negative, you put both negatives. If it's positive, you put both positives. So let's practice some more of these examples. So right here, we do have a perfect square term in the front, and we do have a perfect square term in the back. So we're going to go to our factored form format and do the square root of 4x squared, which is 2x, and the square root of 1, which is 1. And if you do that again, 2x and 1. Now remember, where you had the difference of 2 squares where there was no middle term, then of course you wanted a plus and a minus. That way the middle terms will eliminate. But right here we want a middle term, and we want that middle term to be positive. So the only way that you're going to end up with a positive middle term is if both of these are positive values. So let's put a plus on both of those. Not only that, we need to double check. So if we start distributing 2x times 2x, you're going to get 4x squared. 2x times 1, that's another 2x. And then if you distribute that 1 times 2x, that's another 2x. And 1 times 1, that is 1. And when you do combine those middle terms, you do get the positive 4x that we have up here as the b value. So we know, we have double checked, we know we have factored this correctly. Let's move on to number 2 on more examples. Again, we have a perfect square term right here, and we have a perfect square term back here. So we're going to square root them and plug them into our factored form format. Again, the square root of 9x squared is 3x. The square root of 16 is 4. So on both binomials, you're going to have a 3x and a 4. And if you didn't want a binomial, if you didn't want the middle term, if it were a binomial and you didn't want this middle term, one would have to be plus, one would have to be minus. But since there is a middle term, you don't want these signs to be opposite. You want them to be the same. So what are we going to have, pluses or both minuses based on this middle term b? So we're going to have both minuses. Okay, so both minuses. Why both minuses? Because our b value is a negative 24. And the only way you're going to get that is if both of them are negative. Okay? So if you had a positive and a negative, then the middle terms would eliminate. Let me show you. Because a negative times a negative is a positive, and that's why the last term is positive 16. Let me just show you, because this is what you need to do anyway. Once you get these values, you don't just say, I'm done. You need to verify. You need to distribute. So what's 3x times 3x? 9x squared. What's 3x times negative 4? Negative 12x. And then what is negative 4 times 3x? Negative 12x. And what's negative 4 times negative 4? Positive 16. Now when you combine that middle term and that middle term, you really do get the above quadratic trinomial. Now, if these would have been different signs, then this one would have ended up positive, this one negative. They'd eliminate, and you wouldn't have 3 terms. You'd only have 2 terms.
Negative 12 times
Negative 12 combined with the negative 12, that'll give you a negative 24, which is what you have in the middle. Okay, so what's the difference between the last section and this section? The last section, you had something like 9x squared minus 16. There was no middle term. And you do the difference of two squares. You would square root them and plug them in. But one would have to be plus, one would have to be minus because there's no middle term on the previous section. But on this section, we do have a middle term. We do have a b value. So when you square root it and you square root it, you plug it in. You square root it and you square root it, you plug it in. But since there's a middle value, you don't want this to be a plus and this to be a minus. You want them to be both pluses or both minuses. In this case, both minuses because the middle value is a minus. If you'd end up with both pluses, then your b value would be a positive 24, not a negative 24. So you determine your signs based on whatever your b value sign is. Let's try another. So, by the way, you're supposed to check and see if you could pull out a GCF always, but on none of these we've been able to do that. But we do have a perfect square term in the front, a perfect square term in the back. So let's square root the 16x squared. What's the square root of 16x squared? 4x. What's the square root of 25? 5. So we're going to put a 4x and a 5 on both of those. Now what signs do I put here? Negative. Yep, both negative. Why both negative? Because the b value is negative. If the b value would have been positive, then both of them would be positive. So this is our factored form, but we need to double check it. We need to actually distribute and make sure that it does give us the above quadratic trinomial. So let's distribute. 4x times 4x is 16x squared. So far, so good. 4x times negative 5, that's negative 20x. Then distribute negative 5 times 4x, that's another negative 20x. Negative 5 times negative 5, that's positive 25. And what about those middle terms? What does it give you? It does give you negative 40, so you know you did it right. This last part is absolutely essential, right? Just because you got this answer, it doesn't mean that it's right. You need to double check it by distributing and combining like terms and seeing if it really does give you that middle value. Okay, so let's move on to number 4 right here. We do have a perfect square term right here in the front. We do have a perfect square term right here in the back. It is a trinomial. Let me do the back one in blue. Okay, so let's square root the 9x squared. What do I get?
3x.
3 with an x. How about the square root of 4? What do I get? 2. So we have a 3x and a 2 on both binomials. Now, what kind of symbols do I want right here?
Positive.
Positives, right? Because the b is positive, so I need to have positives right here. Am I done?
No.
No. What do I need to do now?
Double check.
Double check. Now, I might be done, but I need to double check. Check this out. When I distribute 3x times 3x, I get 9x squared. When I go 3x times 2, I get a positive 6x. When I distribute the 2 times 3x, that's another positive 6x. And when I go 2 times 2, I get a positive 4. Ladies and gentlemen, what happens when I combine 6x with 6x? I get 12x. And the b value is not 12x, it's 14x. So we cannot use this method on this one. That's why it's so important to double check. Once you actually do the square root of the first, the square root of the back, and you plug it in your answer format, it's important that you double check because you might not end up with that same b value. So the question is, could you factor any other way? Maybe. The only other possibility, since the a value is not 1, would be to try the long method, right? Step 1 is to multiply a times c. 9 times 4 is 36. And then step 2 is to think of the multiples of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Do any of these combine together to give us the middle value 14? No. So we've tried everything that we can. So what do we say? We say prime. In other words, you cannot factor it. It's not factorable. But the answer on the back of your worksheets will be prime, the one you can't factor it. Okay, guys, so right here, we're going to have this worksheet, and we're going to be practicing the skills of factoring when you have a perfect square quadratic trinomial. So you first want to determine, let me do number 2. Let's determine if this is a perfect square quadratic trinomial. Well, we do have a perfect square term here and a perfect square term here. So let's try to factor it. The square root of 9r squared is 3r, and the square root of 1 is 1. So you have a 3r and a 1, a 3r and a 1. And we need to fill in the symbols here. Now, of course, you don't want it to be positive and negative because that would mean that the middle term eliminates. So you want them either to be both positive or both negative. Look at that middle term. Since it's negative, both of these are going to be negative. So minus there and minus there. So even though it looks like I'm done, we still need to actually double check. So let's distribute 3r times 3r, that's 9r squared. 3r times negative 1, that's a negative 3r. And then negative 1 times 3r, that's another negative 3r. And negative 1 times negative 1, that is positive 1. And of course, when you combine the middle terms, the negative 3r and the negative 3r, we really do get that b value of negative 6r. So that's how we verify that we factored correctly. So we did factor correctly. That's my answer, 3r minus 1 times 3r minus 1. And another way they might write it on the back, on your answer form or answer sheet, they might write it as 3r minus 1 squared. Okay, so let's move on to another one. Let's verify this guy right here. We do have a perfect square term right here in the front. We have a perfect square term in the back. So we're going to use the not difference of two squares, the perfect square quadratic trinomial factored form. What is the square root of 16p squared? That is a 4 with a p. What's the square root of 9? That is a 3. So we're going to repeat that, the 4p and the 3. And of course, we need symbols in here. And remember, the last section you had a plus and a minus because we didn't have a middle term. It will eliminate it. But we need a positive and a positive because the middle term's positive. We put pluses on both of those. So we're going to put a plus right here and a plus right there. And we need to verify. You always need to verify. It looks like we're done, but that might not be correct. We need to verify. So let's distribute 4p times 4p. That's 16p squared. So far, so good. When I go 4p times 3, that's 12p. And then when I go 3 times 4p, that's going to be another 12p. Right? 3 times 4p is another 12p. And then 3 times 3 is 9. And if we combine the 12p and the 12p, we really do get that middle term 24p. So I have verified that this is correct. So that is a correct answer. That's a correct factored form. They might write it as a binomial squared. Okay. Let's look at this next section. It says factor each polynomial. Okay. So if possible, that is. It might not be possible to factor it. So let's jump around. Let's look at number, which one shall we do? We'll do number 10 right here. The very first method that you learned of factoring is pulling out the GCF. So that's the very first method you should always try. If there's something in common in all three terms, you pull out that GCF, the greatest common factor. So what's in common with a 6, a 14, and a 12? Obviously a 2. But not only that, there's t to the third, there's t squared, and there's a t. So you could pull out at least one t from each of those three terms. So if I do pull out the 2t, what would be left on the first term? 2t times what will give me a 6t squared? That will be a 3t squared. And then 2t times what will give me a negative 14t squared? Well, that will be a minus, I'm sorry about that, a minus 7t. And then 2t times what will get us a negative 12t? That'll just be a minus 6. And that's about it with regards to pulling out the GCF. Now the question is, could we continue factoring the inside right there? So on the inside, we do have an a value of 3, a c value of negative 6. So we need to try that long process. Step 1 is to multiply a times c. A times c, that's 3 times negative 6. That's negative 18. That's step 1. Step 2 is to think of the multiples of negative 18. So negative 1 times 18, negative 2 times 9, negative 3 times 6, and that's about it. Out of those three pairs of numbers, which one combines to give me the middle value, negative 7? Don't go to the original, go to the new quadratic trinomial after factoring out the GCF. So if I combine these guys, I get 17. That's not a 17, that's a negative 7. If I combine these, negative 2 plus 9, that is 7. But my middle term is a negative 7. So I have the right numbers, I just have the wrong signs. So let's change them to a positive 2 times a negative 9. That is my correct pair of numbers from step 2. So after that, we're going to factor using that magical shortcut method, okay? So we need to put ax right here and ax. So what is a in the blue quadratic trinomial? It's 3. Instead of x's, we have a t. So I'm going to put a 3t right here and a 3t right there. And then we fill in this blank spots with the pair of numbers from step 2. So put that plus 2 right there, that minus 9 right there. So plus 2 minus 9. And then the fourth magical step is to look at your binomial and see if you could reduce the 3 and the 2 by something, which you can't. So you're just going to rewrite it 3t plus 2. And the second binomial you actually could reduce, divide them both by 3. 3 divided by 3, 9 divided by 3, and you'll get a new binomial that reads t minus 3. So that's your true factored form of this original quadratic trinomial in blue inside the parentheses. Now we still have the 2t on the outside. We still need to put that down, the 2t on the outside. So this is your final factored form of this problem. Okay, so on this final worksheet of chapter 8, we're applying all the different methods that we've learned. Okay, I only want you to do the factoring problems. Maybe on Monday we'll do the solving problems. Okay, but right now just go through and see if you could factor each of these, and if you can't do it, you just say prime. Let's try, let's say, one more, last one, number 16. What could I pull out of there? Well, there's definitely a 7 that you could pull out, the GCF, right? So there's a 7. There is no u in both. There is no m in both. So just a 7. What would be left on the inside? You have a u squared minus 4m squared. Now, on the inside, we do have a difference of 2 squares. That was from the previous section, a difference of 2 squares. So I am going to square root each of those. I'll do the first square root in red. So here's my answer format. What is the square root of u squared? The square root of u squared is u. What is the square root of 4m squared? The square root of 4m squared is 2 with an m. So we really have a u and also a 2m. Now, because this is a binomial, that means that I need the middle term to cancel out if I were distributing. So right here, you don't want the same signs. You want them to cancel out. One has to be plus, one has to be minus. And it doesn't matter which one you put as plus or minus, they have to be different. Now, you don't have to double check when it's a difference of 2 squares. You do have to double check if it's a perfect square quadratic trinomial. So the 7 comes down. Ladies and gentlemen, this is your final answer. So I've done several even problems. I want you to do 1 through 18 today. And there's going to be a different video uploaded to Edmodo explaining the odd ones if you need help on those.